Advanced Math Lesson 34, Summation Notation, Linear Regression, and Decomposing Functions. Summation notation, we have to learn a couple of new symbols here. The first one is this big E-looking thing. It's actually a Greek letter. It's the symbol sigma, and that letter is used to represent the action of summation notation. And then the word summation implies addition, sum being the answer to an addition problem. So we're going to be adding a lot of different values. From here, we have to remember the bottom number and the top number. The bottom number shows us the least value, or our starting value. The top number shows us our final value, or our greatest value. And we're going to be testing the sum of all of those values plugged into this equation. So to show you what that looks like, we'll take an example over here. Starting with this one, we have our sigma symbol. Our greatest value, or our final value, is the whole number 4. Our initial value is the number 1. And we have to test the sum of 1, 2, 3, and 4 plugged into this function of 2x. So what we do here is we take this function 2x and we're going to plug in the first value. Instead of x, I'm going to put 1. That's the first sum. From there, I'm going to add the same function with 2. Then I'm going to add the same function but plug in 3. And then lastly, same thing, plug in 4. So that's what summation is. We take the lowest value, we plug it in, and then every single value up to our final value. And we add up the sum of all of those functions. So the first one, 2 to 1, is just going to be 2. 2 times 2 is going to be 4. 2 times 3 is going to give me 6. 2 times 4 is going to give me 8. 2 and 4 is 6. 6 and 6 is 12. 12 and 8 equals 20. And that's the answer. So summation notation can be very simple right here, or it can be a little bit difficult. What determines how difficult or simple it is the function that you have to plug the values into. So that's an easy version. It's a great way to explain what we're doing. Now let's go ahead and try a little bit harder one. We're starting at 0 and we're going all the way up to 3. So the first sum, I'm going to take this function, I'm going to plug 0 into both of the j spots. All right, so if j equals 0, I'm going to plug 0 into both the j's. Up here we had x. So the first one is going to be 2 times 0 over 0 plus 1. That's going to get added to 2 times 1 over 1 plus 1. That's going to get added to 2 times 2 over, over 2 plus 1. And that'll get added to 2 times 3 over 3 plus 1. So I'm going to simplify all of these into fractions. The first one, 2 times 0 is 0. 0 plus 1 is 1, so I have 0 over 1. Plus 2 over 2. All right, so 2 times 1, 2. 1 plus 1, 2. Plus 4 over 3. Plus 6 over 4. Now, what makes this a little difficult is the fractions. We have to have common denominators. This first one is just going to be 0. And then 0 plus 1 is pretty simple. That's just going to give me 1. So now what I have is 1 plus 4 over 3. Turn that into common denominators. I get 7 over 3. Then I have to add 7 over 3 plus 6 over 4. Again, I need common denominators, so we'll go ahead and rewrite these with denominators of 12. This one's going to get multiplied by 4 over 4, which is going to give me 28 over 12. This one's going to get multiplied by 3 over 3, which gives me 18 over 12. 28 plus 18 gives me 38, 46. So 46 over 12. And can that be reduced? It can. They can both be divided by 2. That gives me 23 over 6. And that would be my final answer, 23 over 6. So the thing to remember in summation notation is to test all the values from your lowest to your highest and plug them all in and then add up all the answers. And that'll give you your final answer for summation notation. Not too difficult. We just have to remember what these new symbols mean. Hopefully I'm not bumping my microphone too much. All right, next we're going to go on to linear regression. Now, linear regression is more or less finding the equation of a line using data points. we have, actually, hold on. No, we don't need calculators yet. Eventually, we're going to start doing these problems with calculators. But for now, as the book first introduces them, they give us scattered data points. This is information from an experiment or data observed in some type of scientific experiment. And then we have to graph the line of the trend. Right now, the book is going to give you the average line. Eventually, we're going to be using our calculators and plugging these data points into our graphing calculators so our calculator can give us the average line. Now, the main thing here is just understanding that all these graphs work in terms of x and y. In this case, this graph, salt is going to be the y value, carbon will be the x value, x being left and right, y being up and down. So when we write our final equation of this line over here, instead of it being y equals mx plus b, it'll be y equals m times carbon plus salt. No, wait, no, I'm sorry, I said that wrong. It'll be salt equals slope times carbon plus b. I'll write that out for you. So traditionally, the equation in this line would be written as y equals mx plus b, right? M being the slope, b being the y-intercept. Now in this case, salt is our y, so we'll substitute salt for y. So in this case, our answer is going to be written as salt equals slope times carbon, which is our x, plus our b. So all we have to do is just find the equation of this line and then write the answer in terms of salt and carbon instead of y and x. So to find the equation of this line, I'm just going to pick 2 points on the line. And I want to pick actual intersections, like this point right here, or like this point up here, or this point down here, to find the equation of this line. So if I use this first point, I'm going to have 40, 0, right? And I'm using the line, I'm ignoring all these scattered plots, because I want to find the average prediction. I'm not using any of these actual points. I'm just using points on the line that they give me. So the first point I'm going to use is 40, 0. And the next point I'll use will be, let's see here, 80, that'll be 100, and that'll be 5, so 100, 5. So I've got my 2 points, I'm going to plug them into the equation, and then I'll use that to find the equation of my line. So first I'm going to find my slope. To do that, I'll go ahead and use slope formula. So I'm going to take y1 minus y2 over x1 minus x2. That's going to give me -5 over -60. The negatives will cancel, and then 5 over 60 reduces to 1 over 12. So in my equation, I have salt is going to equal 1/12 times carbon plus b. Now I just need to solve for b. I'll go ahead and do that by plugging in either one of these. I'll just go ahead and use 105. So if I plug in 5 for salt and then 100 for carbon, you end up getting 1/12 times 100 plus b. To multiply these, I end up getting 100 over 12. Plus b is going to equal 5. This can reduce to, let's see here, that'll be 50, that'll be 6, that'll be 25, and then that'll be 3, so 25 over 3. So I'll subtract 25 over 3 from each side. So b is going to equal 5 minus, off the page again, b is going to equal 5 minus 25 over 3. So we'll go ahead and put 5 times 3 over 3. That's going to give me 15 over 3 minus 25 over 3 gives me -10 over 3, which is what my b is equal to. So my final equation, I'm going to plug -10 over 3 in for b. So final equation is going to be salt equals 1/12 carbon minus 10 over 3. Let me see here. Yep, and that'll be it. One thing is that the book will abbreviate this. Instead of using the whole word salt and carbon, they'll just put S and C. So salt will equal 1/12 times C minus 10 over 3. Also, since this is a problem we're eventually going to be doing with calculators, instead of using the fractional equivalents for each of these numbers, they used the decimal versions of these numbers. And that's something else that you'll also see in scientific applications of math, which if you're in the chemistry class, you'll start learning about significant figures and stuff like that later. So when you do these problems, if you end up with a fraction and you want to convert it to decimal, then just take 1 divided by 12. That's going to give me 0.83 repeating. So this would be salt equals 0.83 with a line over it, C, minus 10 divided by 3, which is 3.3 repeating, minus 3.3 with a line over it. Again, if you put the fraction values, that's okay as well. But both of these are the correct answer. And we're just finding the linear equation of the line in terms of salt and carbon. So that's linear regression. Last thing we're going to learn on this lesson is decomposing functions. And quite simply, that's just if you're given, let me see here. Let's say we have a function plugged into another function like f of g, which we learned in a different lesson. If we have f of g of x equals the square root of x squared plus 1, and then they tell us that, let's see here, they tell us that f of x equals the square root of x, we have to find out what g of x equals. Now, if you remember, if we say f of g, all we're doing is we're saying that we're taking the function of g and plugging it inside the value of x. So, in this case, if f of g yields x squared plus 1 and f of x gives me the square root of x, the value being plugged in for x has to be g. So the value being plugged in we see is x squared plus 1. So that means g of x is going to equal x squared plus 1. We know that's correct because if we were to take this value and plug it in here, we end up getting this. So decomposing functions is you start out with a plugged in function. They tell you what one of them is, and then they tell you to find out what the other one is based on how it gets plugged in. And so it's a bit of a logical exercise. It shouldn't be too difficult, but if you have trouble with it, we'll talk about it more in class. If you have any questions, let me know on Moodle, and I'll see you in class.